let's continue on. So here we need to remember that if we're dealing with GP or AP, there's mainly two angles that you're dealing with. You're dealing with nth or you're dealing with sum. And then you can go on and find other things like rates and all that. But it's these two angles that you always take. Now here they've given us this question. They're saying the third term of a GP sequence is 63 over 4, and the 60th term of the 60th term is 1701 over 32. Find the fifth term. Okay, so now already here they've said find the fifth term, meaning that we're going to deal with this. So we know the formula to use, which is nth is going to be AR n minus 1, not the one for the sum. So we're going to use this one. Now, what is crucial here is to remember also that we only bring in these variables. Okay, it's not a lot of variables. It's only A, R, or N. But here, it looks like we're going to deal with A and R because they've given us N. So they've given us the N here, they've given us N there, and they've given us N here. So this is not something that we need to calculate. It's already been given. So we're dealing with this. So these are two values that we should be working towards, or variables, right? So now, when we are solving these, I think it's very important to take it as a story. Like I've said, here they're saying the third term of a GP sequence is this. So this is a statement. It's a full statement. So we take this statement and create it into an equation, right? So we can say, and don't try to mix them at this point. Just look at them individually. So here we can say third is equal to A R n minus 1. So third here, the third is 63 over 4, 63 over 4, not 64, over 4 equal to A, they haven't given us, R, they haven't given us, but the N this time is 3 minus 1. So we can say 63 over 4 equal to AR2. Okay, so this first part we've handled. This will become our equation number 1. Then we go on and look at the second portion. The second portion says, and the 60th term is that. So we work just with that statement. And that statement says our 60th term, okay, is going to be AR n minus 1 as well. Then we are going to say that the value, which is 1701 over 32, is going to be equal to AR. This time is going to be 6 minus 1, which is 5. And this will become our equation number 2. Right? So if I look at these two equations or equations that we've obtained from the statements, these are enough to give me the two variables here. This does not need to get involved in us trying to find the answer here, right? This is just an extension of what we get from here. Okay, they don't want to say find A or R. They are just telling you that after you find those two, come and apply them here. Okay, so there's just that hidden statement there, right? So now we continue here. There are two ways in which we can solve this. We can take the smaller equation, which is this one, divide it into this one. So you divide this side and that side. It's easier. Or what you actually do is you, because if you divide, the A's will cancel, so you remain with the R. But I think the standard way of doing it is if you can actually just solve for the smaller, in the smaller equation. So for A, for example, here. So, and then replace in the bigger equation. So 63 over 4 is equal to AR squared. So I'm going to solve for A. A will become 63 over 4R squared. Right? This becomes my equation number 3. So I can say replace 3 into 2. Okay, 2, which is here. So now I'll get this and put it here, meaning that where there's A, I can put this value here. So I'll go and say 1701 over 32 equal to, I'll get this whole statement here, right? So it'll be 63 over 4R squared. That's where A was. And then I'll have R squared, 5 here. Okay. So I can take my 4, multiply it to the other side. So it will become 1701 times 4. Then I can take this, take it down here. And I can say 32 times 32 times 63. Like that is equal to R5 over R squared. So here we say that if we have this, it's the same as saying R5 minus 2, which will give me R3. So I've got R3 remaining here. Right. So then I can divide this into there. I get 8. This into there, I get 27. Right. So R3 will become 27 over 8. And so I can find the cube root here and find the cube root there. We said we apply the same concept on both sides. So which will give me R is equal to here to be 3 and down there to be 2. So that's my value for R. And so we can proceed, right? And take this usually into the smaller equation so that it's easier to solve, right? So I'll take this and insert it into the smaller equation, which is this one here. So 63 over 4 equal to AR squared. Then I'll say 63 over 4 equal to A. Then I've got my R, which is 3 over 2 squared. So my 63 is going to be over 4 is going to be here A 9 over 4. Okay, so I can cross multiply there. I'll have 63 times 4 over 9 times 4. So we can cancel these two out. Is equal to A. Okay, because right. So this into there will be 7. Right. So A is equal to 7. A 7 and R is this. Okay. So now what we do is we remember our formula, which is this one. So now we'll say that the fifth is going to be A, which is 7, times R, which is 3 over 2. Now we're looking for the fifth term. So it's going to be 5 minus 1, which is 4. Like that. So this is going to be 7. Okay. Times 81 over, this is 16, which is equal to 567 over 16. So that will be our fifth term. But you'll notice that the fifth term did not have to involve a lot of logic. It's just, you just go back to your initial equation, your initial formula, place your A in there and place your R in there. Where the trick is for you to extract this equation and that equation from those statements. So know the statements that you're going to form the equations from. All right, so this is the first one. Let's try the second question. Again, we have this equation here. It says a GP has first term A, common ratio R, and sum to infinity 6. The second GP has first term 2A, common ratio R squared, and sum to infinity 7. Find A and R. Okay, so we are still going to try and see which ones are our statements that we're converting to equations. So the first is a GP has a first term A, common ratio R, and sum to infinity 6. Okay. But before all that, we need to know, are we dealing with nth term situation or are we dealing with a sum situation? If we're dealing with the sum situation, which one? Is it the infinity or is it the normal? So we can see that we're dealing with the infinity situation here. So already we know the formula that we're going to deal with. The sum to infinity is equal to A over 1 minus R. Okay. We showed how we got to this. So again, ignore the whole story. Just focus on which statements you can convert to equations. So this first statement here again. So a GP has the first term A, common ratio R, and sum to infinity 6. So our sum to infinity is 6. The common ratio is R, which is R here, and then term A is A. Okay. Don't worry about they've used the same letters as the ones in your formula. So you just need to be careful. Okay. All right. So this is our first formula, meaning that I can actually expand this and say 6R, 6, 1 minus R is equal to A, meaning that my 6 minus 6R is equal to A becomes my first equation. Okay, then I look for my second. My second is clearly going to be this one. My second GP has the first term 2A. So again, don't worry about how they've decided to name. Just make sure that you're putting these in the correct places. So here they're saying the first term is 2A, which means that here it will be 2A. Okay. And then the common ratio is R squared. So there it will be R squared. And then the sum to infinity for that case is 7. So it's going to be 7. So I'll say 7 is equal to 2A over this time around we'll have 1 minus R squared, because R this time is R squared. Okay. So this is not the same R as this one. It's just, we could have changed this to say maybe this is X, this is Y, whatever, but we shouldn't complicate it. Let's leave it like this. Right. So then we can expand this to say 7 minus 7 R squared is equal to 2A, like that. Okay. Now we've already got A with this value here. This is that. Now there are two things again that we can do here. Okay. We can take this equation, right, the way it is here before you expanded it, and divide it into this one before you expand it as well. Okay. That will prevent us from going through the simultaneous route. But I like to deal with the first principles. So we'll deal with the first principles. We'll replace, this is already solved for A. So we're going to replace this into there, into here. Okay. So we're going to say, 7 minus 7R squared is equal to 2A. Okay. So 2 what is A? A is 6 minus 6R, like that. We know we can simplify this, but this is the sure way of doing it. So 7 minus 7R squared is equal to 12 minus 12R, like that. Now I'll collect the like terms. This one will go to that side, so it's 7R squared. Okay, 7R squared. This will subtract with that one, giving us sorry, this will maintain it here, and then 7 will go that side and subtract with this one, so we'll get 5 is equal to 0. That's our quadratic equation. This is easy to solve. We can say 7R squared minus 7R minus 5. This is plus 5. Sorry, minus 5. This is plus minus 5R plus 5 equal to 0. Right, so we have 7R minus 1 minus 5 R minus 1 equal to 0. So now we have 7R minus 5 R minus 1 equal to 0. So we have two values of R. R is 5 over 7, and then R will be 1. But remember, because of this formula, the domain here, they say that R cannot be equal to 1. So it takes this out. So our value for R is there. Okay. So we found R. Now we are going to, since we have the value of R, so R, we're going to say that we're going to replace it into one of the equations. It's easier to replace it here. So we'll say 6 minus 6R, 6 minus 6R is equal to A. Right? So we can say A is equal to 6 minus 6R, and then we'll put this value where there's R. So A is going to be 6 minus 6R. R is 5 over 7. So A is going to be 6 minus 30 over 7. So A is going to be 42 minus 30 over 7. This is going to be 12 over 7. Okay, so we are saying that A is equal to 12 over 7, and then R is equal to 5 over 7. Okay, so here we would have found our solutions. Very important for us to ensure that we know we can see the separate statements. And then these statements are the ones that we create to expressions, then expressions to equations. Then these equations we can see, okay, here now we can solve, and then we apply to their question, okay, to their request. So their request here, they've given you statements, and their request is find A and R. So we solved our equations. After we solved, immediately we saw that this actually is the solution they're asking for. Sometimes they'll ask you find the 10th term. Then you can just get this and apply in our formula for the nth term. So, all right, so this is what we had for GPs. We'll do more questions as we go, but I think these are enough to show the picture of how we apply the formulas and all.